So we are moving to the last stop now.
Hi, everyone. Can you guys hear me? Hello, Tokwe, can you hear me?
Yeah, we hear you.
Oh, yeah, fine. First, it's a privilege to actually be here with great individuals. Glenn, good job. Martin, that was a lovely talk in there. And I think it's also like, um, Glenn, you did justice to almost all what I have in the pipeline. I was discussing with Tokwe by the side. Oh, wow, I think I should have actually come first before Glenn doing all those stuff. But that was really amazing. And I think for me as a developer also, it's more of like an eye opener, and it's definitely a tool I will spend most of my time with henceforth, basically. Let me put it that way.
Yeah.
So without
Most
wasting
important, most important is always in security, repeating, right? Repeat, repeat.
exactly.
So it gets sticking and yeah.
Exactly. Thank you so much for that. So without wasting much of our time, let me share my screen, and I hope you all can see my screen. Can you see my screen?
Yeah.
Oh,
Yes, yes.
okay. Sorry, 1 second. Just to be sure I share the right screen, because I have multiple screens open up here. 1 second. Okay. All right. Yeah, so without wasting much of our time, I think my own topic here is just going to be more of like a cap to what Glenn touched, right? And I'll be coming from a developer's angle. And the topic assigned to me basically is secure coding, input validation, and data sanitization. So like you all know, my name is Ezekiel Ogunika. I'm a software engineer. Basically, I specialize in .NET, basically. So that's more of like my core strength. And I currently work with IGT, that's International Gaming Technology. It's one of the leading gaming companies in the world. And I'm in their Canada branch, and that's where I work with the Link Gaming System. So now, before I proceed, I always like to start with this very popular joke. I'm sure most of us must have actually seen it. It's called "Exploits of a Mom," and it's a very interesting joke when security is actually validation or input validation comes into topic. So this is just like a conversation between a school teacher where a call came in, and the teacher was like, "Oh, this is your son's school. We're having some computer trouble." And the mom replied, "Oh dear, did it break something in a way?" And the school authority or whoever calls from the school was asking, "Did you really name your son robots, quotes, single quotes, brackets, semicolon, drop table students with a comment?" Oh, and the mom was like, "Oh yeah, little Bobby tables, right? We call him." Well, this admin was like, "Well, we've lost this year's student's record. I hope you are happy." And the mom response was, "And I hope you've learned to sanitize your database input." So basically, this actually summarizes what we'll be talking in here today, the importance of input validation. And I broke it down into this sanitization and validation itself. And the two key points here, it's just a summary of what this actually entails. When you think of data sanitization, the first thing that comes to mind is this is applied to how you make a data save in a specific context. And the key word to this is actually context. Whereas input validation on its own side is actually checked to ensure that input data are exactly what they should be. You understand? They are exactly what they should be. So in a more sense, what this actually means is that validation itself is concerned with making sure your data is actually valid. And data sanitation itself is about making it safe. Why some of the validation might be useful in making sure data is safe, right? In general, it is not sufficient. So even when data is valid, it might still be unsafe in certain contexts as well too. And this takes me up to the next slide itself. And mostly everything you need to know about validation is actually well detailed in the OWASP chit chat. And I think I wouldn't have been able to put this up without making reference to the OWASP cheat sheet in this regards. So why is input validation itself? Why is it very important, right? And it says, according to OWASP chit chat, input validation is performed to ensure only properly formed data is entering the workflow, right? And information is entering the workflow in information security, preventing malformed data from persisting in the database and triggering malfunctions of various downstream components. Input validation should happen as early as possible in the data flow, preferably as soon as the data is received from the external party. And I think this is where it's very, very key for us as developers, right? Because when you think of security, the very first point you think of is, before you start talking about infrastructure, networking, security, you first start to look at the application itself. So, and the very first part of any solution out there or any system out there itself starts from the developer itself. And I think this is a little we can contribute, because in real sense, we are not security experts somehow, but we still also try to be experts, adding that to our role in what we do, right? So while input validation alone, also, this is also is very important to note as well too, that can never prevent all attacks. It can reduce the attack surface and minimize the impact of any attack that do succeed. Beyond these security implications, data validation is also crucial for software performance, stability, and usability. When processing invalid or corrupt data, an application by returning correct result fail to load or even crash the web server. Missing or insufficient input validation can also degrade the user experience on another level. And I also try to put this also as a developer, most times I try to put myself as the user end. What do I expect? What do I really want? So, this is a typical example, right? If the registration page, for example, fails to detect an incorrect email or maybe a phone number, and the user was unable to also confirm their account. So what's the purpose of me coming up to your site? I want to sign up. I want to enjoy the services. I put in my email, but because in the process, there was a little typo, maybe a space at the back that wasn't trimmed, and I have it stored as it's supposed to be. And each time I keep putting my email, the system keeps telling me, maybe one part of the system itself keeps validating it with a trim text, and the other keeps validating it with the untrimmed text itself. You know, it brings about a very horrible experience itself from a user's perspective as well too. And that's why any system or application that works with input data needs to ensure that it is valid. This applies equally to information provided directly by the user and to data received from other systems. So that in web application, basically, right, input validation is typically understood as checking the values of web form input fields, right? This initial client-side validation is performed directly in the browser. In most times, web, where you do your web validation, but you also need to check what is being submitted at the end of it all. Sorry, oh, that was not what I wanted to do. Okay, yeah. So going back to the next slide now. What's happening? Okay, yeah. There are basically two types of input validation. This also is available on the OWASP site as well too, that can be done on any application itself. The first of it all being a syntactic validation, and the other being a semantic validation itself. So when you talk about syntactic validation, validation should also ensure correct syntax of structured field, your serial social insurance number, the date, currency symbol. Where you are expecting a currency symbol, it should always be a currency symbol, right? And when you think of semantic validation this time around, this should also enforce correctness of their values in the specific business context. So let's say, for example, you're looking at setting up a field where a user is to put in a start date and an end date, right? And a user is trying to put in an end date as a start and putting a start date as the end date itself. Of course, when you're comparing the date over a range, having it flipped surely will give an unexpected result. And also in the place where you're expecting the price, a user is putting in the name of the product. This actually brings a lot of inconsistency, right, within a system. So an application should check that data is both syntactically correct and semantically valid as well. In that particular order, you check if I'm supposed to put in a bank verification number, for example, in Nigeria, or a NUBAN number, which you all know is just maybe 10 characters and the like. We should ensure that this is syntactically correct and semantically, in the sense that, am I putting a BVN number in the place where I'm supposed to put in an account number? Do I really need to have numbers? That is also another aspect we also need to look at before using it in anywhere within the system itself. Moving on. So now we, according to OWASP as well, like I said, this is not going to be done in isolation from the standard defined on the OWASP page. So how exactly do we do input validation itself? How exactly is input validation performed from the developer's angle? One of the approach that was stated is you having a deny list or an allow list. And what this actually means basically is denying leaves attempts to check that given data does not contain known bad content. You understand? Looking from the example of the exploit of a mom joke that was shared at the beginning of the page, right? A web application should allow shouldn't allow special characters like that are known to basically for injections and cross site scripting. Should actually try to not allow any of these in a username, because you're asking for a username. Why should I have these in my username? Ideally, it should be pure plain text. And also the other aspect of it is also like an allow list itself. And this stems from you allowing to check that a given data matches a set of known good rules. And that goes back to the example I created when I was talking about a NUBAN account number. We all know that NUBAN, it's peculiar to Nigeria, right? It's like a nomenclature agreed by the banks to say all banking account numbers are supposed to have a certain digit. And we all know that banking numbers shouldn't be 10 digits. Why should an application give room for you putting in 11 digits, 8 digits, or even more than what is expected in that particular regard? And this is a screenshot of how some of these could actually be done or prevented using a typical model validation from Microsoft, which uses a range expression and also selecting a range, in terms of when the model itself is being presented out. So when you're talking about a name, you should know names are supposed to be only alphanumeric characters are allowed. And when you're talking about weight should always be numbers alone. And this is one aspect to this. But with that being said also, regular expression on its own has some of its own exploits as well, which I think has been proven also in the past, where denial of services could also occur, when you have a regular expression that is not well formed, that could actually expose your application to denial of service. And I think one of the things Microsoft also did in particular was you having like a timeout, setting a timeout for your reg expression itself. So if I'm running a check against a regular expression, I could set a timeout global-wise within the application itself to say any regular expression checks I'm doing shouldn't take more than 5 minutes. With that, you're 100% sure if there's a regular expression check for a malformed regular expression, your service is actually not going to be denied. You can't have an attacker trying to do a service denial by putting in test against your validation, basically. So what Microsoft did in that regard is you have like an attribute that you could set a timeout limit within your app config or within your web config. And for those into cloud these days as well too, on Azure, you can also get this done as well by having a configuration value for regular expressions, not going beyond that. So now, also the second way of getting this done is by validation or sanitization, right? So this has also been proven to be like, this is similar to what Glenn showed in terms of when he was talking about document traversal or file traversal, basically like ESD, which he did justice to in that regard, right? So we sometimes we are developers, we try to fix things, right? We try to like, okay, instead of rejecting an invalid entry, let's try to make it work. Let's try to fix it. Like the example he showed, where we in file transversal, where you're trying to replace every dot with a / from every file name that is being passed. It showed us also a very typical example, what I also have listed here. how this can also be circumvented, right? So in the real sense itself, if you're looking at maybe after validation and sanitizing, to an extent, you probably have to don't really take it too personal when it comes to, as a developer, you want to be sure your application does everything you've done. But like the typical example you show, since we know that this can actually be done at very points during your validation and sanitization, you can decide and say, okay, yeah, I know I've replaced this. Having a local variable itself showing the right part that I want it to be. If it's going to be in a text folder, ensure it's actually pointing to a text folder. And with that aspect, right, if any other thing doesn't fit into what you have in your code, which sometimes people might say, oh yeah, but like, why not just try to fix it, get it done. Let's see how many times you can loop over the, after searching for a double backslash, search for a double forward slash, sometimes it becomes an overkill in the real sense, in that regards. So another thing also that I want us to know here is we shouldn't confuse this validation, right, to data sanitization that we talk, which, like I said, it's a context. We'll surely get into that in the subsequent slide as well too. And one other way also of doing input validation basically is you doing a server side or deciding between a server side or a client side validation. These days now we have lots of several client side development frameworks out there. We try their best also in bringing user experience to the right way that we think of, giving you the right dialogue. But most times, right, the bottom line is you should never always trust your clients, no matter how robust they are. Don't trust your clients. Anything could have happened and you don't really have a control over, right? Always ensure you do a server-side validation. So a common misconception, right, especially for beginners, is to rely on HTML and JavaScript to only validate forms data. Indeed, HTML allows defining patterns, required fields, searching sorts, character limits, requiring specific fields to be filled. However, there's no HTML attributes or JavaScript code that can be modified on the client side because you don't have access to it. Hackers might also submit this form using a call or HTTP client. So the client side is absolutely not a secure layer to validate. So like I said, the bottom line is don't always rely on the client. By the time you get to the server end itself, ensure a validation is also done at the server side of your scripting as well too. And that takes me back to the sanitization aspect of this topic itself. And what basically happens here is, whereas validation is concerned with making sure data is valid, right? Data sanitization is about making it safe. And I think I gave a context to this earlier, right? And one of the prone or more of the common danger of you not sanitizing data, basically, like because you feel you've done an input validation, right? Your input is valid, but the whole concept is what you see is actually not what you get. When it comes to data sanitization itself, you're looking at the text, it looks, oh yeah, it's valid, it has the right stuff, it has the right details itself, but does it really mean that the fact that it's valid where it's supposed to be when the input validation has been done, does it really mean it is safe in a different context itself? And that's why we have to go back to common consequences of improper input validation. Like we all know, cross-site scripting, it's one of the common attacks that are actually out there. It's a security vulnerability which enables an attacker to place some client-side scripting, usually JavaScript, right, into web pages. And when other users load these pages, right, the attackers can run their script, do whatever it is, steal cookies, session cookies, change the content of your web page, you understand, through dumb manipulations or redirecting the browser to another page. Several XSS vulnerabilities generally occur when this application takes user input or output into a page without validating or basically without doing encoding, which we're going to get into also in details. So like, as we all know that context is very important in any discussion of cross-site scripting, browsers and encoding. In the browser, when we talk about context, we're primarily talking about where context is being rendered rather. There are 4 contexts in a typical web application. You have your HTML body, HTML attributes, JavaScript, and of course your CSS as well too. And according to OWASP cheat chart, to prevent or limit the impact of SSS, it has been proven that there is actually no single technique to solve cross-site scripting. So with the right combination of both defensive technique, right, to prevent XLs, one of the recommendations also is to you depending on the framework security itself. And like I said, for me, from the .NET side of it, right, Microsoft did a very good job when it comes to how best you can prevent cross-site reference scripting rather in your application, and the framework does a good job to that, which by the time we'll get to the next slide, we'll surely see how we can have these prevented. Okay, yeah, so let me go to some, looking at how we can do protecting your application against XSS rather from the .NET approach itself. And this is actually like an excerpt from a proper documentation from Microsoft. And there's a reference there, which I can share also later on. It said at the basic level, cross-site scripting works can be tricky by your application into inserting a script tag into your rendered page, or by inserting an event into elements, right? Developers should use the following prevention steps to avoid XSS into the application. Number one, never put untrusted data in your HTML input unless you follow the rest of the steps above. Like before you even render HTML values, right? First thing first is untrusted data is in any data that may be controlled by an attacker, HTML form input, your query string, your HTML headers, the data source from a database. As an attacker may also be able to breach your data. Also, like if there's a database breach and you're rendering stuff, an attacker might have breached your database as well. And by the time you're rendering some of these onto your application, whatever it is the intention of the attack is, can also be executed. And the step says that before putting untrusted data inside an HTML element, ensure it's HTML encoded. HTML encoding takes characters such as a scripting tag and changes them into a safe form like this. Can you see what I have highlighted here? Like the alt, oh, sorry about that. I'm clicking, takes me to the next page. And also before putting untrusted data into an HTML attribute, ensure it is also encoded. HTML attribute encoding is a superset of HTML encoding and encodes additional characters such as and, you know. And also before putting untrusted data into JavaScript, place the data in an HTML element whose content you retrieve at runtime. If this isn't possible, then ensure that data is JavaScript encoded. JavaScript encoded takes dangerous characters for JavaScript and replace them with their hexadecimal version. For example, a greater than will also be encoded using this as well. Then before putting untrusted data into your URL query string, ensure it is URL encoded. For more information on that, you can actually get that using this link, which I can share when this slide itself is being shared. And also another consequences of you not having a proper input validation is one like which has been overemphasized as well too, is SQL injection. You are prone to having an SQL injection attack if a proper validation is not being done as well too, right? And what exactly is SQL injection? It's just an attack that exploits variability in your input validation to run arbitrary commands in the database. It can occur when your application uses input to construct dynamic SQL statements to access database. It can also occur if your code uses stop procedures. Now, you know, there's always this concept that, oh yeah, by you going the route of stop procedures, you're safe, right? But what exactly do you do in your procedure also? The fact that you're using a stop procedure to access to do your DB queries, your CRUD operations in your DB as well too. Does that still mean what you're practicing in your stop procedure itself? Does that still make it safe as well for the data that you're having in there? So using the SQL injection, the attacker can execute arbitrary commands in the database. All SQL statements, including the SQL statements in stop procedure, must be parameterized. Parameterized SQL statements will accept characters that have special meaning to the SQL like single quote itself without problems because they are strongly typed. And this is one typical example of a stop procedure, right? Which takes product name, of course, being parameterized, your start date being parameterized. But the downside to it is this is a dynamic, I don't know for those that are into the .NET and maybe normal SQL syntax as well too. This is you having a pure literal XML itself written in text, formed within the stop procedure, and you're running and execute syntax itself, which is always known as dynamic stop procedure itself. So you're constructing your text base with plain text and the likes. And with these also, the fact that you have a parameterized variable, a possible SQL injection is still can be carried out with this, because you have your SQL written as pure plain text, building your text within the product, just like the example Glenn did, within your product name itself. And a malicious SQL query can be inserted into the product name itself. And by the time you run this last line called exec SQL, you're not just only running your normal intended SQL code, but you're running an injected SQL query rather, and which can really cause devastating harm into your application. And according to Microsoft approach of getting things done also, this is a proper way of you running a similar, same thing, same concept, same selection criteria, but in a proper way without using the dynamic SQL query. Yeah, you can see it's still the same like, but this will surely is way better than you having this executing dynamic stop procedures as it is, because this is actually more of like a strongly typed, and will do a lot of really, like I said, SQL will only accept those characters that are within the context of SQL itself, and any other one relating to you exposing some stuff would never be executed in this kind of approach itself. I know some of the security experts might say, "Oh yeah, with this we can still find a way around it though," but like according to Microsoft, this has been proven and it has been tested, and it's been proven to be very effective as well too. And so with that being said also, right, for we as developers, right, doing validation, it's kind of very it's not something you can just think of on the fly, think through. Maybe because of a year of experience, you can get it. Like the framework Glenn talked about is also one very good place we could use these tools also in trying to test our applications and see how they. So validation can be a useful tool in limiting SSL data. For example, a numeric string containing only the characters of 0 to 9 won't trigger an SSL attack. Validation becomes more complicated when accepting HTML in user input. Parsing HTML is difficult, if not impossible. Markdown coupled with a parser that strips embedded HTML can be used as a safer approach for accepting rich input. Never rely on validation alone. Always encode untrusted inputs before outputting it, no matter what validation or sanitization that has already been done on your application itself. And the general practice is that encoding usually takes place at the point of output, and encoded value should never, ever be stored in a DB. You understand? And the fact that during encoding, right, when you encode at the point of output, this allows you to change the use of data itself. For example, maybe looking at an HTML to a string query value, for example, without having encoded values, before you search and allow, can take it, some of the boxes can take advantage of any changes, fixes, made to those encoders, and they can actually exploit your system and the like. So for me, I feel when we talk about input validation and data sanitization, this lies more because an attacker, like for we as developers, it's our responsibility to ensure that we spend more time in ensuring that the best we can do is what we are doing in terms of validating an input, and the best we can also do in terms of rendering the same data that we have already back to the user is also being properly done in the right way, so as to also protect the user. And like I said earlier, the very best form of protection in any web application, in any system, is from the source code itself, it's from the application itself, then before any other form of vulnerabilities can actually set in. Like I said, if I'm to talk much on these, I think it would just be like going over what every other person on this call has actually said. Most especially, I keep making reference to Glenn tool. And like I said, this is one very important tool we can actually use as developers, to check. There are several vulnerabilities that you can think of. These few ones that are chosen are just common that we know of. But lately, as the technology advances also, attackers also they are, by the day, they are also innovating, trying to look at vulnerabilities, and also from the angle of Martin also, You have a DevOps environment in your system running fine, doing your CI/CDs, your build pipeline are running. But like your dependencies itself, is anybody checking? You're using the version of maybe .NET Framework 2.21, 2.2, for example, that Microsoft itself doesn't even support. Microsoft said this is out of support. If there are vulnerabilities within those applications, be rest assured Microsoft is not going to release any patch. But within your organization, you still have your key core concept, your key core applications running on those frameworks. You know, that's more like setting a house on a, putting a house on a light fire that could really explode anytime. So like when we talk about security, input validation, data validation, DevOps, and, you know, people basically, the process, and in fact, of course, the technology itself are the things we actually require in having a proper or a more secured environment. So it doesn't just lie with us as developer also, it lies with the process, which these days, DevOps engineer comes in. As a DevOps engineer also, you should also be thinking security. Don't just think process, don't just think shipping my code to pipeline, having a proper redundancy, having a proper contingency plan is what makes a proper DevOps. Security also is also very important. And finally, just to round up what I have lined up for today, is also the fact that we can't do this alone. And that's why efforts are being made in having tools that could help us as developers in doing lots of vulnerability tests as well too. And I think the OWASP are actually doing great also in setting up the right standards, and where you can actually go check things before you push out your application to your production environment, run them against most of these checks, see how you're doing in terms of input validation, in terms of sanitization, how exactly you're doing, and in terms of processes also, how exactly are you doing as well too. So I feel at this point, without taking much of our time, this is my little presentation on input validation and data sanitization, and I really appreciate your audience. And I would like if there's any Q&A at this point.
Yeah, thank you very much, Ezekiel. That was awesome. That was an awesome talk from you. And do we have any question from the audience in respect to the validation and sanitization? Because I equally agree, most times some developers are always very reluctant. You know, by the time they start, they fix functionality issues. You now start telling them we have security issues to fix. They're always reluctant. I've seen experiences on that. So all they care about is the functional aspect. So now, bringing it together with security issues for them to fix, they always see it as another task, a big task from the part. So it's just a matter of balancing things. You know, most times they always want someone to come in to assist in respect to that. But if they have it at the back of their mind, just as you've said, pushing your codes to CI/CD, you must, even from the stage of developing your code, there must be security in it, so that you keep checking it even before pushing your code. By the time you check it, it will go a long way in giving you a clear status of security. So thank you very much, Ezekiel, for coming for this event. There is no question on ground for you, and we hope that whenever we call upon you next time, you answer us. What time is it there in Canada?
This is 11:20 here. Still quite morning here. Yeah.
Yes. Yeah. We are in the afternoon here. So thank you very much for coming on the program.
Thank you so much for having me around too. And it's a pleasure meeting great minds all on this call.
Thank you very much. So greet your family and greet your friends over there.
Thank you.
So this is where we are going to be cutting the event for today. We thank everybody who comes around, despite the fact that it's weekend. Some of us need to rest. We still have our time to be on the program, on the event today. So if you need any slide, you can drop your email. I'm going to forward the slides to you later on, and you can keep tab with the community as we will be dropping one or two information in respect to OWASP. So I'll be dropping the WhatsApp group and also some necessary details on the chat now. So you as well can drop your email in case you need any information. So that one will be passed across to you. So thank you very much for your time, and have a wonderful days ahead of you.
Bye, everyone.